All right, so we're going to talk about sinusoids and harmonics today. Right? It's a continuation of what I did on Friday. We're going to start with the one-link robot and use that as a mechanism to understand sinusoids and harmonics. So what we have here is an arm that can be brought to a certain position. So think of that as the hand of a clock. All right, so you can take the hand of a clock to a certain position and just leave it there. And then you have an angular position theta, which is measured from the horizontal x-axis. And based on that angular position theta and the length of the link L, we did two things last class. One was that we were able to find the projection of that link on the x and y axis, and we used sine and cosine functions to do that. All right, so if you project the link onto the x-axis, you would get L cosine theta would be the length, or the projection on the x-axis, and L sine theta would be the length of the projection on the y-axis. Okay, so if I asked you to plot this, so as a function of radians, so now that was just one snapshot in time. You put the arm at a certain angle, and you measured x and y. Now what if I did this 360 times for one full revolution? I'll put it at 1 degree. I'll note the x and y position. I'll put it at 2 degrees, note the x and y, 3, 4, 5, 6, etc. All right? So let's see what happens with the x. When theta is 0, x would be equal to, the length of the link is L. When theta is 0, x would be equal to L. All right? If L is 1, you're right. You have the right idea. If L is 1, when theta is 0, L is going to be equal to 1. Now what happens to theta as the angle increases? What happens to x as the angle increases?
It goes down.
It goes down. And what happens to the y component?
It goes up.
Till
90 degrees.
Till 90 degrees. After that?
Goes back down.
Goes back down. So if I were to plot all the x positions as theta changes, what would that look like? So what I would like to do is, put this arm in different position. 0 degrees, 1 degree, 2 degree, 3 degrees, etc. For each degree, your x is going to decrease and your y is going to increase. And that goes on till theta gets to 90 degrees. And then between 90 and 180, your x is going to increase in the negative side, and your y is going to decrease to 0. And then in the third quadrant, your x is going to go from -1 back to 0, and your y is going to go from 0 to -1. And in the fourth quadrant, y is going to go from -1 to 0, and x is going to go from 0 to 1. What I have here is two plots. One is supposedly in red and the other one's in blue, and I don't think you can see it very well on the screen here. But can you tell me which one is x and which one is y? There is one curve that starts at 0 and there's one curve that starts at 1. Yeah?
The red one would be y, the blue one would be x.
The blue one would be x because when theta equals 0, x should be 1 and y should be 0. All right? That's our initial point there. And I do this 3 times I'm going around. So for one full circle, you'd go from 0 to 2 pi, and I've drawn this 3 times. And what we're going to do now is see how we can accomplish this using MATLAB. Are you familiar with opening up a new script file and writing your own script and running it in MATLAB? No? Okay. So in the previous class, I told you there are 2 ways in which you can use MATLAB. One is right here at the command window. All right, so here you can type cosine d of 45. All right, so you're using it as a calculator. You just type whatever you want to do, and it'll give you the answer right away. All right, that's fine if you want to just do one calculation, one at a time, a calculation. All right, if you want to do a whole series of calculations, then using it as a calculator is not very efficient, right? You'd like to put all your questions at once and have MATLAB give you all the answers. And the way you do that is using what's called as a script file or an M file. So there are different tabs in MATLAB here. I'm going to go to the Home tab, and I'm going to select a new script. Okay. In this new script, I can say A equals 5, B equals 4, C equals A times B, D equals A plus B, and E equals A minus B. Okay, so I have three questions here really, or three entries. One is I'm assigning a numerical value to two variables, and I'm performing a whole bunch of mathematical operations on them. Okay, so I'm going to save this. Okay, so let's call this. So you'll save it as an M file, .m file. All right, I'm going to give it some random name, and I'm going to save it here. And I will go back to my Editor tab, and I'm going to run this program. Okay? And when I run this program, you'll notice that MATLAB first assigned values. So junk is the name of my program. It created a variable A. It assigned to it a value of 5. It created a variable B, assigned to it a value of 4, and performed the three computations that you asked MATLAB to do. You wanted to multiply 5 and 4 and store that answer in a variable C. You wanted to add 5 and 4 and store that in a variable D. You wanted to subtract 4 from 5 and store that in a variable E. All right, so that's a very elementary example of what's called as a script file. Okay, and you saw that plot in which we generated x and y as a function of theta. Now we're going to try and do that one step at a time. Okay. So this is the file that I typed up, and it's also on Blackboard. Now let's see what happens when I run this file. Okay, so I'm going to close out. It generated two figures. I'm going to close out the second one. We'll get to that later, but let's look at the first one here. All right, so on the x-axis, I have theta in radians, and on the y-axis, I have the x and y position. Now let's see how I generated this figure, and let's do it one step at a time. So what we need to generate this is we need a table. We need a table with a whole bunch of theta values. We need a column which has x value, and we need a column for the y value. Okay? And x is defined as L times cosine theta, and y is defined as L times sine theta. So the first thing we need to do is define what L is, and we have to create a whole bunch of thetas. All right, so the very first line in my program is a definition, a line that defines what theta is, and I'm using a command called linspace or linear space to define what theta is. And if any time you need help with MATLAB with a certain command, all you have to do is go to the prompt and simply type help, the name of the command, help linspace. And that'll tell you all about that particular command. And it'll also give you a whole bunch of examples on how to use that command in a program. Okay? So what does linspace do? Linspace, the way I've written that, creates a linear space or a whole array of numbers starting at 0, going all the way to 6 pi, okay? And that array is going to have 2,160 entries in it. So let's create a simpler linspace instead of creating something complicated like that. Let's go to our junk file here. And let's say we create a linspace. We're going to call that ABC. Okay? And I don't know how to use linspace, so I'm going to look up linspace, and it says linspace should be written like this. It should have the x1, x2, and n, the initial number, the last number in the array, and how many intervals. So let's say I would like to create an array that starts at 0, okay, ends at 10, and has 20 entries in it. Okay, I'm going to save and run this. You see what it did? It created an array called X. Okay, it started at 0, ended at 10, and it had 20 numbers in between. And that's how you get this. You go from 0 to 20, 0 to 10 in 21 steps. Okay? So that's how you get this array. So we are going to use that command linspace. Okay? So we use this command linspace to go from 0 to 6 pi. 0 to 2 pi is one full revolution of the arm. We're doing that 3 times. So we create that. We define what L is. L is the length of the link. In this case, I set that to be equal to 1. Okay? And X is L cosine theta. So you have defined what L is, you have defined what theta is, and it creates an X. Okay? And you similarly define what Y is. Y would be L sine theta. Okay, then I'm going to plot that. I'm going to create a figure called figure 1. And plot is a command that you use to plot. And again, if you need help with plot, it's as simple as go to the prompt and say help plot. And it'll give you a whole bunch of examples on how to use plot. Okay? This is a very detailed and useful help tip. Okay, so what I'm doing here is I'm plotting 2 curves. The first curve on the x-axis, I plot theta versus x on the y-axis. And the second curve is theta on the x-axis versus y on the y-axis, where x is L cosine theta and y is L sine theta. All right? This R that you see there, that is telling MATLAB to put that curve in a certain color. All right? And then you have to label the graph when you have a graph. So the command to do that is x label. And you can tell what the x label is. So if you look at this plot here, what do we have for an x label? We have theta in radians, right? So we have to enter that as the x label. And how do you do that? Well, you simply type whatever you want, but anytime you want to use a Greek alphabet, you would put a backslash. If you put backslash and theta, instead of writing it out as a English theta, it's going to convert that into Greek. And for every line in the program, I've written something after the percentage sign. Anything that is green after the percentage sign is called as a comment line. Right? That is to help you understand the program. It's easy to understand when I talk about it, but if you go home and if you were to look at it, you might not understand why I did certain things. And please read what's written there in the green, and that'll tell you why I did what I did. All right? So for example, the x labeled slash theta, the comment is to label the x-axis. You use that. And when you use backslash, MATLAB converts that into Greek alphabets. Okay? So you give it an X label, and you give it a Y label. And what I also have is MATLAB will automatically create the size of your plot. So the X variable, which is theta, varies from 0 to 6 pi. And the Y variable varies from L to negative L. Okay? So MATLAB will automatically generate the size of your space in which it's going to draw the graph. If you wanted to draw it in a bigger space, for example, I want to, let's say I comment this line. I'm going to put a percentage sign. Anytime you comment the line, MATLAB is not going to execute that line. So right now I commented this line, and I'm going to run this program. Okay, so you see how this thing is all over the screen, and you really can't understand what this thing looks like. What I want to do is I want to zoom out and shrink this thing smaller. That way I can see it better. And so instead of going from -1 to +1, it would be nice if I went from -2 to +2. That way I can see the curve a little bit better. So you can allow MATLAB to choose the default size of your plots, or you could do it yourself. And if you did it yourself, I'm telling MATLAB the X variable, X-axis size, goes from 0 to the largest value of theta. Max within parentheses theta would imply the largest value of the array theta. That would be 6 pi. And on the y-axis, instead of going from -L to +L, I want it to go from -2L to +2L. Okay? So you will notice that when you plot this, you can see a sine and a cosine function much better. Okay? Your name? Hello?
Sorry about that.
Please don't play with your cell phones during class. It's a very, very, very bad habit. All right? So I take my time, prepare for the class with the intention that I'm going to come here and teach you and help you learn. All right? As soon as you come, we take attendance. You can leave after that. Please don't stay into this. It's very disrespectful. Professors are not going to like it. All right? Just a note. Okay. All right. So let's go back to this. All right. So you set the limits of the axis. And finally, legend. So if you look at this plot here, you can see this little legend here. It's telling you that the blue line is the cosine line and the red line is the sine line. You have to indicate that, otherwise it becomes very difficult for a user to know what is what. And that's what the legend command does. Okay? So the legend command allows you to tell you what color line is associated with what. Okay, any questions on this so far? Okay, yes.
The theta, how did you, I guess how you actually got the theta?
I use the command linear space. Okay, I generated an array or a linear space consisting of theta, and the linspace command, which is right here. All right. So that command is telling you that create a variable called theta, which is an array really. It starts at 0 and it ends at 6 pi. And the reason why I chose that number 2160 is pi is 180, 2 pi is 360. 6 pi is 360 times 3, which is 1080. And I did twice that. 1080 times 2 is 2160. So I took that 0 to 6 pi and I chopped it up into 2,160 divisions of half a degree each. So it's the same as taking the arm of the Link robot, moving it half a degree at a time. And for each half a degree, you create a value of theta. And for each value of theta, you generate the corresponding values of x and y. Okay? Any other questions? All right, so this comes with practice. So that's why I'm not asking you to generate your own code. You can use my code for starters, but in the subsequent weeks, you'll have to generate your own code. And we will give you a lot of help in recitation. And if you're still not certain, if you're still a little uncertain, you could always come and ask me during my office hours. All right, so let's go back to our plot here. So I took a picture from MATLAB and I posted it here. By the way, if you want to save your MATLAB pictures, if you also notice, by default, MATLAB generates a plot that will have theta is actually an array consisting of numbers, right? 6 times pi is 3.14. 6 times 3.14 is 18 point something. Right? So it's going to generate numbers between 0 and 18 point something. That is not very meaningful to us, right? We want it in terms of pi. So if you look at what I have here, I don't have 0, 5, 10, 15, 20. I have 0, 2 pi, 4 pi, and 6 pi. And the reason why I do this is, if you look at this plot here, you know that when you start at theta equals 0, the x is L. And when you go, the value of x changes, starts at 1, goes to 0, minus 1, 0, and 1. So it goes a full range from 1 to 0 to -1 to 0 to +1. So when it does that, it's set to have a period. So the same thing repeats after the arm comes back to the 0 position, all right? So this x cosine theta and x sine theta, they're all periodic with a period equals 2 pi radians, all right? So this chapter consists of two portions. One is sinusoids and simple harmonic motion. So in sinusoids, this is what we're talking about, sines and cosines here. It's periodic with the period 2 pi. So that periodicity we denote by the letter capital T. And these two curves are periodic with a period 2 pi. And I'm going to show you how to change the tick marks from 0, 5, 10 to 2 pi, 4 pi, and 6 pi. Okay, so these are not in your notes or anything, and you have to follow me as I do this. All right, so you can go to your figure, and you see this button here, where it says Show Plot Tools. I want you to click that button, and it'll open up all your plotting tools. And I want you to click on the number here. And you see the ticks radio button there? You can click on that. And instead of 0, 5, 10, 15, you can change it. 0. Okay. I'm going to change this to pi, which is 3.1417. And I'm going to type pi. All right. And I'm going to, actually I'll call it 2 pi. 2 pi would be 6.28. And it'll be 2 times pi. Okay, 4 pi would be 12.56. And I'll call it 4 times pi. All right. 18.78. And I'll call it 6 times pi. And when you hit apply, you see how it changes the x-axis from, instead of 0, 5, 10, 15, which are not points where the curve changes periodicity. It's periodic with period 2 pi. So 5, 10, 15 means nothing to me, but 2 pi, 4 pi, 6 pi means something to me because that's the point where you go full circle and you start again. Okay, so that's why we change the x-axis to reflect the periodicity of your curve. All right, so when you're plotting the x and y coordinate as a function of theta, you get a plot which is periodic with period 2 pi. What we're going to do next is we're going to plot it as a function of angular frequency. So all those were snapshots in time. You move the link of the robot to a certain position, you freeze time, you measure x and y. All right, so now what if we had a continuous motion at a certain rate? So we define a term called this, the Greek alphabet omega. Omega is the angular frequency. All right? So there's a relationship between theta and the angular frequency, and the relationship is theta equals omega times t. Okay, omega is the angular frequency in radians per second. You multiply it by time, which is in seconds. The two seconds cancel out, and you would get theta in radians, or angular position. Okay? So this is the relationship between angular frequency, angular position, and the time variable t. Okay? So omega is the angular frequency, and little f is the linear frequency. Right? The unit of angular frequency is in radians per second. The equivalent linear frequency is defined as little f, which is in cycles per second. Right? And remember in the previous plot that I showed you, I told you that those curves are periodic with the period capital T. You can use that capital T to find out what your linear frequency is. 1 by the time period of periodicity capital C is your linear frequency, which is denoted in cycles per second. And the relationship omega is theta times t. Right? And you can write it in terms of linear frequency as omega equals 2 pi f. All right, let's go to MATLAB and run this. All right, so here's the second plot. Okay, so on the x-axis, I have, in the previous plot, on the x-axis, what was my variable? I plotted theta on the x-axis versus x and y in two separate plots on the y-axis. Now there is a time variable that has been introduced. So I'm going to plot time on the x-axis and position on the y-axis. So what this is telling you is that what does the link of the robot do as a function of time? So before it was as a function of position, what were x and y. Now as a function of time, what is x and y? Okay? So we have to define what the angular frequency is. If a link goes a full circle, which is 2 pi radians in 1 second, the angular frequency is 2 pi radians per second. So let's go to the MATLAB program that I have. All right, so what I've taught so far is section 6.1 in your book. And again, look at the comment lines. That'll help you understand this a lot. So that section, that is for section 6.1. That is position, and section 6.2 is angular velocity. Okay. All right, so we define angular velocity omega as 1 radians per second. Okay. So in 1 second, it's going to go 1 radian. So the periodicity, the time period t, is 2 pi divided by omega, and that comes from here. Okay? Okay. Let's go back to our MATLAB plot. Okay, so now we have, just like we created our, so anytime you plot something, you have a function, you have something called as a dependent variable and the independent variable. In the previous plots that I showed, the independent variable was theta. The dependent variable were x and y. You pick a certain value of theta. Based on that, you get a certain value of x and y. All right? So theta does not depend on anything, whereas x and y depend on theta. So theta was your independent variable, and x and y were your dependent variables. Here, t is my independent variable that's on the x-axis. So I have to generate a whole series of t's using the command linspace, and I'm plotting as a function of time, not theta. So my x and y here, previously there were L cosine theta and L sine theta. Now there are x equals L cosine t and y equals L sine t. So I don't call it x again because I've already used the variable x. I'm going to define a new variable called xx and yy. And I define xx as L cosine t and yy as L sine t. And what I have here is I created a linear space. So let's see what capital T should be in this case. Omega was 1, so capital T is 2 pi. Right? So I go from 0 to 2 pi in time. So 0 to 6.28 seconds in time. And I do it in 100 steps. So I divide 6.28 divided by 100. And I increment, starting with 0, that value with every increment. So I'll generate an array consisting of 100 entries, starting at 0 and ending in 2 pi. And I will plot I will first generate two arrays, xx and yy. That'll be these two columns, L cosine t and L sine t. And I'm going to create another figure. I'm going to call this figure 2. Okay, so I'm plotting t on the x-axis versus xx on the y-axis. That's the first curve. And the second curve would be, again, t on the x-axis and yy on the y-axis. And I'm going to make the second curve a certain color. And I'll do the same thing. I'll make a label for the x-axis, a label for the y-axis. I'd like to set a font simply because the default font is very small and it's not really visible. So I'm going to change the font. And I set the range of the x and y axis here. So the x-axis, we're plotting time. So the left end would be 0, and the right end would be the maximum of the array t that I just created using the linspace command. And the y-axis goes from negative L to positive L. And then you have legend. The slash theta converts it into Greek here. Okay? All right, so let's run this. Okay? So we're plotting x and y variables as a function of time instead of as a function of theta. And our angular frequency, yes? Under figure 2, what is the R for? Let me see where you see the R. Oh, that indicates the color of the curve, if you wanted a certain color. If you don't put that, it's going to generate everything the same color. You really can't tell one from the other. Yes? Yeah, that's purely the label. So if you look at the plot, you would see exactly what you typed there. Time equals this. Yeah, that is the units in seconds. No, if you want to change that, if you want to change the color of the label, yeah, you could go here and do it. So let's say we go to this. So you could go click on the time here, and there you can set the color to whatever you want it to. Okay? So there are two ways to do this. You can do it either in the text, or you can do it graphically. So you could do R in the text, or you could do it here graphically. So to begin with, graphical might be easier for you to manipulate, but as you get better with MATLAB, this is a time saver. So every time, if it's graphical, every time I have to go and manipulate that manually, there I can just type it up. And what I do is, once you use MATLAB for a semester, you have a whole bunch of shortcuts that you set aside. And anytime I want to use it, I just go open up my file of shortcuts and I cut and paste from there and generate a program. But if it were this, I'll have to go and make the settings every single time. And that's really a pain in the butt. All right, where were we? Okay, any questions on the scripting part? All right, so the gist is you go to home, you start a new script, you save it as a .m file, you go to editor, and you hit run to run the program. It compiles the program and then runs the program. Okay? All right, and how do you save the figures and paste them in your Word document when you turn in a homework? You could go to File, and you can say Save As, and instead of, you could save it as a figure, which means it'll save all your settings, or if you simply want to save it as a JPEG or a bitmap file, you can do that as well. Simply save it as a JPEG file, and you can insert that into your Word document. Okay? So on your homework assignment sheet, there are 5 problems assigned for homework in this particular chapter. With what I've done today, you should be able to solve the, I think number 6, problem number 6 and problem number 8 or 10 are assigned as homework. You should be able to do those 2 problems before you come for class next time. It's not due until next week, but you should be able to finish them by Wednesday. And what I'm going to do on Wednesday is please take your time and practice with MATLAB. I will not give you this detail of a step-by-step instruction with MATLAB from now on. The code is there. You don't have to try and do this yourself. Read every line of the code and see what it does. And what you can do is you don't have to type the whole code and run it. When I was a new user, what I would do is I would write a few lines, run it to see how it runs, see if I've made any mistake. Because if you type the whole thing, it'll give you a lot of mistakes, and then it becomes hard to troubleshoot if you're a new user. So write one line, output that on the screen, look, see what it looks like, and then go to the next line. Okay? So for example, if you're creating a linspace, you could just do one line at a time. Just create a linspace, see if that works. Then create x equals cosine t, where t is your linspace, see if that works. Then generate sine. And then you generate a plot. And do it step by step, and you'll be all right. Any other questions? Does anybody have, it should be in your content section. Yeah. So I'm responsible for these 3 weeks. And I think, I'm sorry, 6, 5, and 6, 8, not 6 and 8, 5 and 8. All right, so you should be able to do 5 and 8. And in the next class, hopefully I'll have enough time to complete all of this, 14 through 23. Yes. You don't have to do it on MATLAB, but it's going to be very difficult for you to generate a plot. I mean, your alternative is to do it on Excel. All right, you can't do it by hand. It's going to be very, in hand you can probably just pick 8 or 9 points and it's going to look very jagged. So you want a lot of points. So you have to generate a plot using some computational tool. I would prefer if you made a very tough decision of not using Excel. All right, if you get used to MATLAB, your life becomes really, really, really simple. Okay, so please try not to use Excel. And you don't have to write your own code. I'll give you all the answers. The idea is for you to get comfortable with this and not be intimidated by this. Yes. I left it as L, not 1, because in the homework problems, they'll say let L be equal to 100. So if L changes, I don't have to go and change my axes. It'll automatically scale with L. Yep, so if you're doing the homework problem using the code I gave you, all you have to do is, if the homework problem says the link length is 100, simply go and change this to 100. Okay? And if you run this, see, instead of 1 to 1, it automatically scaled it, or negative 2 to 2, it scaled it from negative 200 to positive 200. Okay?
Should we buy the MATLAB book, or will you teach us pretty much everything we need to know?
For this course, I will teach you everything you need to know, and you don't have to buy a MATLAB book. There's a free introduction to MATLAB book in the ebook in the library, Temple Library. You can download that and practice from there.
So basically for the home exam, you just print that out and do it.
Yep.
And it just goes to just for the graph and the other 5 minutes.
I'm sorry, one more time.
So just 6, 5, and 6, 8 are the problems you have to show in that course.
Yeah. I'm not sure I understand your question. A little louder, please.
So the 2 problems we're using MATLAB
Yep.
for now.
Yep.
For the rest of the problems, for
You should be able to use MATLAB for the first 8 problems. All right. So my goal is to teach you how to do all the problems using MATLAB. Okay. And if you feel like you're not learning, what you could do is pick some random numbers and try doing it by hand in a calculator, and also see if that matches with what you have from MATLAB. That way, if you want to get a paper and pen feel for it and still want validation, you could do that. Okay? But my goal is to teach you enough MATLAB that you're able to solve every problem using MATLAB. Yes?
Can you get SolidWorks on this unit too?
Yes, you can get SolidWorks on your computer as well. You know the room 312 where we had our class on Friday? Right behind the back wall where the printer is, there are 2 rooms. I think it's 306 and 307. That's where the tech guys sit. And what you could do is you could go there, and if you gave them your ID card, they would give you a flash drive. You could take it home, or just sit outside there, install it, and return it back to them. All right. So in that flash drive is the installation files for SolidWorks, as well as a set of instructions and the product identification key, etc. Unfortunately, yes.
You get it off the download site?
For MATLAB, you can go to the download site, but not. No, the problem is it's too big, and they have to chop it up into bits, and we used to do that before, and that didn't work out very well. Students were a little confused about that, so this seems to be an easier solution.
Do they have SolidWorks on the computers at Tech Center?
There is a graphics lab within the Tech Center, and SolidWorks is installed in the graphics lab, but not in all the other computers.
Sorry, I have a question. So in the engineering building, is there computers that can use in free time or just being no classes to use SolidWorks?
I think the library has SolidWorks. I'm not very certain about that.
The library has SolidWorks and MATLAB on all computers.
And it's in the Tech Center. It's only the graphics lab that has.
There's only the graphics lab.
Yes.
For the lab, you want us to print out our calculations for the MATLAB unit, or do you just want to have the
For the Fridays lab, I don't think I asked you to print out the MATLAB calculations, did I? Let me double check what I asked you. The instructions are online. So if you go to, I think it's the laboratory information. So what to submit: one document with tables, these 2 tables, and a set of SolidWorks screenshots with angles and lengths, dimension for each line in the table. Okay? All right. Any other questions? All right. So is my pace comfortable enough, easy enough for you to understand? I hope you don't feel rushed. All right? All right. I'll see you on Friday. So Wednesday, I'm sorry. So remember, Dr. Sadegapur is going to teach about 15, 20 minutes of complex numbers, and then I'm going to continue with this.